right. Thank you very much for coming to my little chat here about how we are working on implementing data domains with Dremio in Nordea Asset Management. So my name is Anders BOGSNES. I am a master expert at Nordea Asset Management. If you want to know what that is, come find me afterwards. It can be your free icebreaker question. We can get to know each other. So just to get a feel for the crowd here, it's like who knows what a data domain is? Let's start. Okay, cool. And data mesh. Okay, cool. Then I think we have a good talk for you today. So I'll be talking for about 20 minutes, and then I hope we get a little Q&A going towards the end. And if not, then yeah, you have 10 minutes back in your life. So obligatory, who are we? Nordea Asset Management is a fully owned subsidiary of Nordea, the bank, who you may or may not know. But we are thus a much smaller company, around 1,000 people, based in Copenhagen and Luxembourg, with smaller offices spread around the world. We have around 240 billion euros in assets under management, and we're one of the biggest ESG shops. So if you're not familiar with ESG, it's about basically green stocks, green bonds. If you're interested in investing sustainably, then ESG is where you want to be. So a little bit of history. We've actually been doing data domains for 4, 5, 6-ish years. Before data mesh was a thing, we got some new blood coming into the company, and they looked around and they saw, I was like, wow, there's a lot of duplication in business capabilities happening all over the shop. So I was like, well, that's bad, right? So basically, they took inspiration from domain-driven design and said, let's try to draw some boxes around these capabilities and try to organize ourselves so that we have one domain that is responsible for a business capability. I was like, that's cool. And then data mesh came out and the world blew up. And we said, yeah, that's exactly what we're doing. It gave us a bit of the missing pieces, the three other elements apart from the domains, right? So the better competition governance, the self-service infrastructure, yeah. So basically, it just fit really well with what we were trying to do. So we were very early adopters of trying to move into the data mesh world. So for us, data domains, we have 12 of them. So one example would be ESG, as I mentioned, is one of our core products. They would expose a data product. So there's one way in to get that data. The reference data team, as you can imagine, have a lot of reference data, have a lot of data products. Very important that there's only one source of truth for reference data. So they would have a number of data products that they expose. Performance calculations. Again, they're doing calculations on performance, benchmarking, and that sort of thing. Very, very, very important. There's only one source of truth there, because now we're talking things that are going to customers about their investment status. And limits would be another one. I'm not going to list all 12, but just to give you a flavor of what we're doing. So again, the principle is each one of the domains, they always need data from some of the other domains. So the only way in is through that data product ports. There is no other way of getting the data, is the idea. So each of the domains, they're fetching data from each other, back and forth. Looks beautiful on paper, right? So we kind of did it the opposite way, in that most companies do the tech first, and then they try to figure out the governance. We were quite lucky in that we had kind of done the hard work of defining the domains, because this is actually the hardest part. And like this work of trying to figure out what domains we should have and what they should do, I mean, that took us probably a couple of years of hard work and negotiation to get that down. And we're still not there, but we've taken like the major steps in that direction. So now we have to figure out the tech. How are we actually going to do this in practice to make it easy for all these domains to expose a data product that is easy to consume and has high quality and all these fun things. So again, a little bit of history. We have a bunch of smart people that comes with being an asset manager. We had a core application that happened to have an Oracle database as the backend. These very smart people, they figured out we have a database. All the data is right there. Let's just use that. So a lot of it was understanding the data model of the core application and knowing that in the security table, if column Z has an ID of 16, that means, oh, that's an FX swap, and you can actually join it with dimension over here, which is named something completely different. But if it's 2019 or 5, no. Then it's completely different instruments and can't be doing with that at all and give you completely different results. It won't actually tell you because the keys are the same. It just gives you garbage. So not the best way of trying to share data. It requires 15 years of experience in this core application. Every time that they decide to update the core application, of course, they're going to break schemas. They haven't given us any promises about the internal schema of their application. So don't do this. Bad idea. It worked for us for some time, but yeah, don't do that. So next step, of course, let's just copy the data. Copy the data out into a bunch of SQL servers. Now we have data products, right? We have it all in control. We can model it. Everything is fine. I mean, not quite, right? You still have a bunch of SQL servers that you don't really have a lot of control over what people are accessing and what they're not accessing. So next phase, REST APIs. Put an API in front of everything. We tend to be a bit of a one-track mind. Once we latch onto new technology, everything is that. So the whole company ran after building REST APIs for everything you can imagine. So that's all well and good. We have a data product now, right? Well, I mean, we're still doing all this copying back and forth, and I mean, REST APIs are good for some things, but what if I want to react to something happening, which happens in trading a lot? So we do have actually from Nordea Group, their IT provider. They run one of the biggest Kafka installations in the Nordics. Cool, we have that. That's cool. Let's put all the data onto Kafka. Then we have one point where you can subscribe to a topic and you're sure to get only the model data as it happens. Beautiful, right? Now we have data products. Now we're done. We can go home. Well, I mean, what we've actually done here is sure, we do have modeled, beautiful data that is defined in one place, but where is the complexity? So again, you have to remember, you can't get rid of complexity. You can only move it around. So now these guys who are accessing the data and writing a SQL query and getting all their data, now they're sitting in the middle of here and they need 10, 15 different data products. Oh, all you have to do is just call these 10 APIs and then you get these 5 Kafka topics and then you join them together and you're done. That is very far away from a user-friendly experience for an analyst. Super smart. They might know a bit of Python, but they're not programmers or developers. And we just took away their favorite tool, which was SQL. We said I can't use that anymore. Well, what's the solution? Bring back SQL. So our model is to bring in a lakehouse. So not a centralized lakehouse, because we don't want to go back to the bad old days of centralized data warehouse, where basically centralized bottleneck for all your data modeling. Each of the domains, they have an S3 bucket. It's a bring your own bucket lakehouse, which basically lets us put a query engine on top. And now, spoilers, it's Dremio. I'm sure that's not a shock to anyone. Now, our analysts get to write SQL just as they used to, and they get beautiful modeled data products over time. Can you imagine getting 10 years of data from a REST API and do that 10 times? So to get this working, there are 2 things that we had to focus on. So one of them was the architecture. So we define an outer architecture and an inner architecture. So for most domains, you have some data source. That could be internal, external. We provide a lot of data. It's a part of our business. We extract that into the inner architecture. Now, we don't have any opinion on your inner architecture. That is the domain's responsibility. There is someone who's responsible for that domain. If they want to pass around Excel sheets and paper napkins, they're responsible for their outcomes. We're not there to babysit them. But they do have 3 responsibilities. They have to publish to Kafka. We still love Kafka. It's great for your eventing. It's great for reacting, which is very important in our line of work. It's just not great for long-term analytics. So you must publish your model data onto Kafka. You must publish your model data into a data catalog. So the data catalog is not just about what the schema is and so forth. So the Kafka topic, for example, has a defined schema. It must be an arrow. It must be published in the schema registry. And the same for any other data source. You need to show what your schema is. But this is our data quality hub. So to enforce data contracts, I need to trust that your data that you published actually lives up to the standards that we have agreed in common. So we have a common forum where we can bring up complaints and that sort of thing. So you've defined an SLO, an SLA, and some data quality checks for your data. And every time you publish a new set of data, you also publish a fresh data quality check to the data catalog. So in the bad old days, I used to pull your data, run all the checks that I needed, and then proceed to use the data. And you do the same with my data. And we'd all do it with each other's data. Now we have one place where I can go and get the source of truth for data quality instead of all of us trying to check each other's data all the time. And finally, you have to publish into what we call the analytical plane. So that's that S3 bucket. It has to be Apache Iceberg. So that's what we require. Notice I didn't mention anything about a query engine. So our philosophy is sensible defaults. If you know what you're doing, you can go ahead and read those Iceberg files directly with like PyIceberg or Spark or Athena or whatever you want. If you don't know what you're doing or you don't care, then we have our sensible defaults. So we have chosen Dremio for this. And there are a few different reasons why Dremio fits our use case. So one is it's Apache Iceberg native. So if you are in your architecture, again, you don't really know much about Iceberg or anything like that, you just write SQL, insert into table. It's an Iceberg table in S3 by default. They don't really need to know all that much about the underlying structures. The other part is the semantic layer we get in Dremio. So remember, we still have all those on-premise databases and all that mess that I mentioned in the beginning. We're getting rid of it, but we all know we have some skeletons in our closet. So using Dremio lets us not have to do the big bang, which was one of the reasons we actually opted for a Lakehouse directly instead of going through the cloud warehouse intermediate step. And we kind of got to leapfrog that generation and go straight to Lakehouse. And in Dremio, we get to have a pointer. So if I select start from transactions, I actually don't know where the data is because I don't care. That's the domain in our architecture's responsibility to point Dremio to the appropriate place. And when they are ready, when they have successfully modeled it and put into Iceberg, then you can just repoint back away from on-premise legacy into Iceberg. And that's how we gradually get off of our legacy platform instead of saying you can't use our platform until you have upgraded, because that's going to take years. And no one wants to be the first one. So this is the tech side. Dremio also has a lot of nice other capabilities in terms of caching and reflections and things that just speed up these queries a lot. But architecture is one thing, but the second very important thing is people. We can't do any of this. This all looks nice on paper if our domains don't have the appropriate teams. So we are big subscribers to team topologies. Everything I'm going to say now is just taken straight out of team topologies. Is there anyone who has not seen team topologies before? Okay. Get this book. It is an easy read, and it is, I believe, it's the future of how to organize teams in companies, especially if you want to try to build data products and data mesh. So the core is we have our value streams. The value stream is the one actually delivering value. They are end-to-end cross-functional teams that has all the capabilities that they need to successfully deliver business outcomes. It also means that they have a owner who's responsible for those outcomes. So again, they get to choose whatever tech they want to use. They just have to defend their outcomes. So if they want to use Athena and they get better results, great. Maybe we can learn from that. But if they're using Excel sheets and they're delivering half the outcomes of all the other teams, then maybe we need to talk to the one who's responsible for these outcomes and try to figure out how to help them. So speaking of, we also need a platform team. So you need that self-service infrastructure layer. Again, cognitive complexity is the killer. Offloading, like our value streams, they need to know what Kubernetes is. They need to write what Kubernetes manifests. They need to know what Iceberg is. They need to know how to write a performance Iceberg table, but they don't need to know how to run Dremio. They don't need to know how to run a Kubernetes cluster. That is something that we can offload onto the platform team, build a thin abstraction that they can then subscribe to, and shift all the cognitive complexity down to the platform team. So how you want to structure this is more of a context thing. So for us, we want the slimmest possible platform team because we want to be able to Google the answers. Other companies I've seen, they build very thick platform teams, lots and lots of abstractions, super easy to deploy one thing. But if you're trying to like shift over into something else, or you don't understand what's going on, you can't Google it because it's a home built platform in the end, right? Those abstractions aren't in ChatGPT. And finally, and the most important one, I'm biased, this is my day job, enablements. So again, I just mentioned that the value streams need to know what Kubernetes is. They need to know how to write these manifests, how to Dremio appropriately. We can't expect that everyone we hire just knows that, or that the entire company just picks it up by themselves. It would be silly to try to build a platform and just throw people in there and say, hey, go learn how to swim. So enablement is persistently allocated. So that means we have dedicated people who can be allocated to a value stream. They're not allowed to own anything. So we don't write any code. We just help teams write code. So we teach them best practice in terms of testing, in terms of CI/CD, in terms of deployment practices. I run the Python enablement team. We have a lot of quants. They're very smart. They learn Python University, but they're not software developers. But I can teach them how to become a software developer. It's really hard to teach a software developer how to be a good quant. So this enablement, this goes across multiple aspects. So we have enablement for Kafka, for example. We will introduce enablement for Dremio, and teams can invite us in. So again, we don't go where we're not wanted. We're invited in to help add value. And it's a two-way street, because how does the platform team know what to build? They're not out there in the trenches, right? They're busy building clusters and maintaining them. So the enablement team gets a front row seats. They have the technical level to speak to the platform team, and they can translate the pains that the value streams have in their day-to-day work. So given this trinity, you actually can build domains that actually work. So given that, we've covered the architecture that we saw as a requirement, the tech that we needed as requirements, and finally the people. That is our secret sauce. That's how we've delivered on data domains, how we're delivering on data mesh. And that's all that I had for you today. Thank you very much for your time. So I'm hoping there are some questions. We have one down there. You want to do runner?
Hi, I love that talk. There's so much in there that I agree with. It's really good.
Thank you.
The domains is definitely a thing, deciding on what the right domain is. I wondered if there are any tools or tips or anything you would suggest about how you came to that domain structure.
Talking. Lots and lots and lots of talking. So basically, as I mentioned, we spent a few years trying to nail this down. We started with a small core group. Some of this fresh blood that came in to have some new light and new eyes on it. It's very easy to get trapped into your current organizational structure as the basis for your future domains. And that's the trap that you have to make sure you don't fall into. So having that core team in the beginning come in from outside with fresh eyes and say, this shouldn't be one domain just because you have the same manager. That's not relevant. We're going to slice it here because that's what makes sense. And then you go through the battles of, because the organization likes to be the way it is. There's some inertia there, right? But Conway's law is a thing. So inverse Conway's law is kind of our way of trying to tackle that. But it takes a lot of time.
Did you find that you did manage to break away from Conway's law effectively?
To some extent, yes. So I'd say we're 80% happy with where we are. But getting the last 20% is still a journey. So as with everything that I've shown here today, I'm showing you the perfect picture on the slides. Yeah, we can talk about the messy stuff afterwards.
Thank you.
Any other questions? Yeah, we have a question here.
Right. Hello. Okay.
Hey.
So you said you put all your data, all your as well. You obligate your teams to put it on Kafka as well. So
Yep.
do you do that as well for all your batch jobs, all your slow-moving data as well?
Yep.
And what's the value behind to do it also not only for operational and events-based data?
Yeah. So there's two things. So if we go back to here. The part that I haven't drawn in here is one of the main ways we actually do this publishing is using Kafka Connect. So the easiest way, again, as a sensible default, if you don't know what you're doing, push it to a Kafka topic, set up a Kafka Connect to Iceberg. And then it kind of just works out of the box. The other part is it's really hard for you to predict what other domains need you for. So the slow-moving batch jobs, we still have those. But the fact that when they start coming in, you might need to react updating a report, for example. So you could do something where you're polling, the analytical plane to see has the data arrived, or you just say, I subscribe to the topic with the slow-moving data. Whenever it arrives, then either I can choose to read it or just go to the analytical plane because now I know it's there because it's already been synced. So Kafka just gives you a lot of opportunities, and cutting off those opportunities at the pass what seems a bad thing to do. Yeah.
Thank you very much. More of a technical one. So you effectively got like a streaming ETL listening to Kafka.
Mhm.
What does that physically look like? Is it like a PySpark job that's just listening for things to do, or it sounds like a lot of like architecture just sitting there waiting for stuff to happen, right? When you've got like one cluster, finite resources, stuff like this. Is that just the reality of things?
Well, so the Kafka cluster is a shared service across all of Nordea.
Yeah.
The sensible defaults that we have for the teams is to use Airflow as our like core orchestrator, and to run arbitrary Docker images with that.
Right. So Airflow is listening to Kafka. Is that right?
No, so Airflow would be responsible for the sort of the extract inner architecture,
Right.
and then publish to Kafka.
Right.
Again, if you know what you're doing,
Yeah.
then we encourage you to go straight to the eventing pattern.
Okay. Yeah.
But again, a lot of our teams it still operates in a batch world
Yeah.
because it is a lot of reporting. It's a lot of calculations. So you take your day's data and then you figure out what was our performance on trades yesterday. That's hard to do in like a single trade. You need like the full day's view to actually figure that out. So we have a lot of things that are naturally batch, and we have a lot of things that are naturally streams.
Okay. Right. That's me.
Well, when I think about how an asset manager operates, well, there is some kind of production world where you collect data, you make investment decisions, and there's all the trading, trade processing stuff. Is the stuff you're talking about here just to say the post-production fallout that you then use for reporting and things, or do these actual, what I would call the production world of the value chain, does this actually link in here and take back information, or is this just downstream?
A bit of both. So, like a lot of the trading execution stuff would happen on the stream layer itself, but we often have things where we need to refer back to analytical data in order to decide if, like, should something be done. So, the other thing we have here is that we don't really care that much about the outcomes. We just know that if we do this, then we have smart people who can build inner architecture that provides business value. So how they choose to do that is actually not that much of a concern for the outer architecture. It's more that now we have the foundations. It's like basic science, right? Now they can start building on top of our basic science and produce business outcomes.
Yes, but for example, the positions they use to make investment decisions on and build that. I mean, you got probably a portfolio management system for that. and that's outside this, and it just then feeds its results in here for whoever wants to run analytics on it. Or
Yeah, to some extent. That's not my expertise, so I'm not gonna be a bit big on that one. But yes, in a sense.
Thanks.
So this might be a stupid question, but I
No
was
stupid
wondering.
questions.
I was wondering if on your data sources side, do you have any like relational databases like CDC that you do into Kafka as well? Like,
Yeah.
how do you handle like, do you have these like soft delete issues and stuff? Or,
Yes. So we use Kafka Connect a lot, and that is one of the core ways that we get data from our data sources into whatever the inner architecture is. Because it is so straightforward to do, we have done the enablement so that the teams kind of know these are the default sensible configurations for doing that. But yes, then we have to have a talk with them what you actually want, because like soft deletes, for example, is one topic. You need to compact the topic. You need introduce tombstones. Like there's lots of different corner cases that each team needs to decide how they want to handle. So that's where the enablement comes in on the Kafka side.
Yeah. So for example, imagine there is some relational database with this, they delete some rows, it goes through, it ends up in your kind of first layer in Iceberg. But how do you then propagate that change? Like, do you use like some other tool in between Dremio, like DBT or something like that will propagate the change, or Kafka Connect will do that as well? Or
yes, we don't write back to our sources.
So I mean, so imagine on Iceberg you have like a raw table where you just track all data. So you will have like a delete event. So okay, now it's soft deleted, and then you have some other Iceberg table analytical that essentially depends on the previous Iceberg table. So now you want to keep it in the raw table, but you want to delete it in the like presentation layer table. Like, what do you use to handle that?
Yeah, so most of the modeling that we do, that's one thing I forgot to mention, is that because Dremio is just SQL, we get to use DBT as our transformation layer. So we are big users of the DBT Dremio plugin. But it's like the complete decisions of, is this a entity that needs to have the entire history, or is it a representation of the current state? Those are modeling decisions that the domain makes, and they just define it in their entity, in their data contract that says like this entity here is the current state without any deleted rows or anything like that. This one over here is archive table. It's just an append of everything that's happened.
So you don't have any like real-time dashboard issues, because DBT will work great for that case, right? Where you have like a traditional like presentation layer table and it propagates nicely and all of that. But do you ever have like a real-time scenario where they delete something, it propagates through the system, and you immediately need to indicate that as well? Do you use anything else? Then
so I mean, it's a problem that everyone who's working with data will have at some point. So it's more about understanding the context about how we deal with each individual case. But the short answer is absolutely we have problems.
I guess I was curious about what tool you use, but
data modeling techniques. No real tool for it.
All right,
fair enough.
Hello. Thank you very much, first of all, for the presentation.
Thank you.
A question with two questions, actually. What's your choice of data catalog, and who's responsible to publish the data quality rules, and who is excellent?
Sorry, can you repeat that?
So what's the choice of your data catalog, like what product, and also who is responsible to defining the data quality rules, and which team and what system is running them?
Yeah, so we looked at a lot of data catalogs. The one we are currently trying to implement is Data Hub. It's not 100% settled that it's that one, but that's what we're running a POC with that. And because it has support for exactly what we're going to do in terms of data contracts. So the definition of the data contract, it's owned by the domain. So they say this is our product. But the whole idea of data mesh is that you are my customer. So I can offer a product I can put on the shelf, but if no one's buying it, then we'll come back to the owner and say it's not doesn't work for your customers. You need to change it. So it's again shifting that mindset to be business oriented outcome as an output of the value stream, and having that business owner be responsible for it means that you have that point of contact. And conflicts happen, right? So we do have our like governance council where these domains can meet and they can exchange problems or issues or things like, I need this foreign key, or like this key that you're using right now, it doesn't work for my use case. What can we do about it? Or even like scheme evolution, like I'm planning to do some breaking changes. I can see in my lineage graph that you're going to be affected. How can we together handle it in a good way? So in the end, it is people communicating,
Is that okay?
but just tech aided.
Yeah.
But,
Yeah, it's fine.
Yeah. Okay, we're out of time. Thank you so much for all your questions and for your time.